Let me take this opportunity to introduce myself. My name is John Odhiambo, and this channel is all about having fun with design and manufacturing. I have been in the product design and manufacturing world for over 20 years. Designing and building stuff is not just a career for me, but it's also a hobby. In this channel, I share some of my fun projects, like the e-scooter build, the laptop holder build, the CNC router build, etc. Feel free to go to my channel and check out these videos, and also don't forget to like and subscribe. Thanks. Before you begin reverse engineering an object, you have to answer three main questions. 1. How does the part function? 2. How was the part manufactured? Lastly, what are the critical features? Part function. The steering knuckle is part of the suspension system that houses the hub bearing, wheel hub, and the brake caliper. The tie rods, ball joints, and struts are also connected to the mounting holes as shown. Part manufacturing. Most steering knuckles are made out of cast iron. The critical features are then machined to spec. Critical features. The features and surfaces critical to the functionality of the steering knuckle are the ones that get machined to spec in the video. We are all probably familiar with high-tech reverse engineering tools like a 3D scanner. These work pretty well, although you still need modifications to the model before you can use it. They are also still quite pricey. You can also probe and digitize all your critical features, then build material around them to complete the project. You can also use a conventional caliper and gauge pins to collect the size and location data from the features. Starting with the strut mounts, we first measure the distance A between the holes because this reflects their functionality. The holes are also located at the same vertical height. Now tie the holes to the main bearing axis using dimensions B and C. Ensure that this relationship is carried over to manufacturing if you use a manual machine to reproduce the part. Now we move on to the brake caliper mounts. Measure the X and Y dimensions, which represent the feature functionalities, that is A and B. Then locate the hole pattern to the bearing axis. Again, ensure that this relationship is maintained during the manufacturing. Using the same logic, complete the rest of the critical features. Remember that there are a million ways to skin the cat. I started with a cube representing the stock material. I then added the critical features and surfaces. Now, I went ahead and sculpted out the rest of the waste material to reveal the final model.